This inverter is manufactured in Target company. It has a 1 kVA maximum power, 12 volt battery input, and 220 volt pure sine wave as an output. Also, we manufacture up to 3 kVA till nowadays. Now, I'll talk or mention the specification of this inverter. First, we have the pure sine wave of this inverter, and we will see it on the oscilloscope. We already connected the terminals of this inverter to the battery and the AC in to the AC source. And now we can see that the probe of this oscilloscope is already connected to the load. These are the loads, and this is the wire which is connected to the output of this inverter. Now we will turn on. We will turn on this inverter, and we can see how the waveform of this inverter began to rise till it reached the maximum peak. We will continue mentioning the second specification, which is the overload protection. Okay, here we will turn on some loads till it reaches the overload. Okay, this is 200 watt lamp, there is 400, 600, and now 1000 watt. Here we will see that there is an overload, and after a period the inverter will cut off. Okay, there is a cut off now, and we can see it here, and there is no voltage or waveform. Okay, we will reduce the load, and after a period this inverter will turn on automatically. Okay, we can see it, and we can see the waveform rises again till it reaches the maximum peak. Now we will mention the dynamic short circuit protection. Okay, here is the device that will make the short circuit. It is two wires which is connected to each other. Okay, now this is the output. Okay. Okay, there is an overload. Okay, and the gain. And the gain. And now we will make it for a long period. Okay, we can see that there is a cut off after many dynamic shortcuts. Okay, and the voltage equal to 0 volt, and after a period it automatically turns on. Okay, and the voltage began to rise till it reached the maximum peak. And now we will talk about the charging, which is one of the specifications of this inverter. First we will turn on the AC source, and we will wait till this inverter begin to charge the battery. Okay, now we can see it when the lamp turns on. Using the DC clamp meter, we can see the current across the battery, which is around 15 amperes. Okay, and now by reducing the voltage, to less than 200, the current is still about 14 amperes, and if we reduce it again, we can see the current still above 10 amperes. and if we reduce it about 130 volt, the current will be about 9, and at a certain voltage which is less than 110 volts the charging will stop and the LED of the charging turns off. Now we will raise it till it reaches the maximum volt, which is 250, and we can see that the current began to rise till it reaches the maximum charging current.